Hey there, and welcome to another channel video where I am going to review the brand new Tooltop ET828 Pro oscilloscope and multimeter. The ET828 Pro is the upgrade version of the ET828 model that was already packed at the time with a 1 MHz mean bandwidth in terms of oscilloscope with 2.5 megasamples per second, and now supports up to 10 MHz bandwidth with a sampling of 50 megasamples per second. The most amazing thing is that they squeeze even more the price and is now competing with normal 200 to 500 kHz oscilloscopes. It's even cheaper than the previous and inferior model. I really want to show you this, but now let me tell you that this product was sent for review free of charge for me, and I didn't receive any payment from Tooltop for making this review. That said, I want to thank Tooltop for their continuous collaboration with the channel, and also you, my viewer, that sponsored this channel by using the affiliate links on the screen or in the description before making your purchases on AliExpress or Amazon, sponsoring the channel without paying a cent more. It's really a big help to maintain the channel. My sincere thank you. Without further ado, let me show you the key features. Well, this is the box where the ET828 Pro is delivered. Yeah, it has no reference to Tooltop brand, but yeah, we saw this before. Let's open it and see what's inside. Okay, we start with a simple operation diagram. Let's see what this is. Okay, this is just explanation of the buttons and everything else. Only one side. I don't believe this is the user manual, maybe it is. We have a set of lids. Yeah, not the most flexible ones, not at all. Simple ones. Let's see what we have in the top of the lids. Okay. They are quite pointy. Yeah, let's take it out. And also we have the multimeter and a user manual. Black and white, but it's in English and it seems organized, yeah. So also a user manual. Let's see the device. Okay, it's not big, it's a small multimeter, not the smallest, but yeah, it's not a big device. Okay, doesn't have that plastic cover for protection, and this is battery operated. Okay, let me get the batteries to put on this and I will be right back. Okay, let's try again. They have an instruction how you should install the battery. So first, let's see, like this. First you should install A and B and then the middle one. Let's do that. Okay, first one, second one, and third one. Nice. Okay, we have here the multimeter oscilloscope ready. So this is all plastic, no rubber to prevent falls or slipping. The aim of this is to be really accessible. Well, I will not say cheap, but to be very economic, very accessible to everyone. So we have 4 function buttons and 2 auxiliary buttons R and S. A rotation it takes some pressure to be able to rotate the knob. When you rotate the knob, let me show you. Yeah, it takes a bit. Okay, so it seems that we have the DC oscilloscope and also AC oscilloscope. Okay, I don't see connection for probe, so we should use these ones. Okay, voltage, yeah, multifunction like ohms detection and so on. Capacitance, frequency, milliamps, amps, and off. Okay, so you can turn it off from the right or from the left. Okay, it seems easy enough. Let's see what we can do with this and how the menus are. To show you how this works, I already repositioned my camera. You can start with the oscilloscope in DC or AC mode, and I will start with the oscilloscope. I will use the DC mode. You may figure out that DC it will be much similar. So we have these two buttons. The R button is basically the auto in an oscilloscope. I already have my function generating outputting a square wave of 1 kilohertz. It's basically the normal for probe compensation. So I will start by pressing R. As you can see, he already configured the oscilloscope or the waveform. So in the top you have the operation mode DC, then you have the time base, the divisions in terms of amplitude, the trigger modes, and basically it's triggering, and also the battery charge. Obviously in the middle you have the waveform, you have some measures here in the bottom, and then you have the description of the function keys here also in the bottom of the LCD. You can change the brightness. I left this in the lower brightness, so I think it is better here in the recording. And you have basically 3 ways of configuring this with time, voltage, and triggering. Let's start with the time. The time, it will allow you to change the time base. As you can see here in the top, when I change, it updates the time base. It has this annoying beep that I was not able to find out how to disable or change the mode. So you will hear a lot of beeping during this review. So let's continue. You can press F1 to exit the time division. Also in voltage, it's the amplitude. You can increase or decrease the amplitude like this. And again, exit. And finally, you have the trigger. For the trigger, you can change the slope, rising or falling. And also the modes. You have single, normal, and auto. If you want to change the level, just press level, and you can move this. Oops! You can move this little indicator up and down. If you continue pressing, it will not do anything. So a lot of beeping, as I told you. And if you want to center again, just press reset, and it's on center. One thing that I didn't found is how to move the waveform on the screen. Probably have to read this again, but that's not something that I was able to see. Okay, so in terms of waveform, as you can see, it's pretty simple. It works pretty well, very accessible and intuitive. RR gives you auto, and if you press S, okay, it will stop the waveform on the screen. Let me see if I can show you better here. When the waveform is stopped, you have 2 options. Or you press again and run the oscilloscope normally, or again you press for about 2 seconds and you have these records that are saved in the system. You can use the right and left keys F1 and F2 to go through the system. You can erase or save the waveform. For example, I'm going to go through the system. You have this one, some tests I already made. And right now we have position 3 free. I will save the waveform here. Okay, so as you can see, we have the waveform saved, and all the measurements are saved with the waveform. You have it all in the bottom. Okay, to leave this menu, just press again S for 2 seconds, and we are back to the oscilloscope. In terms of oscilloscope, there is nothing much more that I can show you. After I will see some waveforms drawing on the screen, and we'll test the accuracy of the readings. Okay, so now we should change to multimeter. In multimeter, so by pressing select, it's F3, and you have select across most of the voltage. You can change between DC, AC, and then you have Hertz and the duty cycle percentage. So we have the frequency, obviously, the voltage, 2 voltage, and 2 frequencies. Yeah. So you have here the auto range, and if you press rel, you will have the relative value. So in pH you have peak hold. It will tell you the highest or the maximum and minimum values registered. You can also do a stop on that, and you can reset the values. Okay, going back. Finally, we have in the RNG or range button, you can manually change the range of what is being measured. As you can see, it's changing the decimal point over this. So we have voltage, we have resistance. Again, all the same values can be used here. If you press select, you change to diode modes and continuity, and I think again to resistance. So that's it. Back again to capacitance. Capacitance, you only have the rel button, nothing else. It's on auto mode always. Then we have duty cycle and frequency. Okay, you can select between frequency and percentage, so duty cycle. And finally we have the current measurements with milliamps. Again, DC milliamps, AC milliamps, and that's it. We have again the peak holds for maximum and minimum, rel, and the range. Right now it's on auto, but you can change it manually to another range that you prefer. One thing that I didn't find out is how to put again in auto mode. Let me try to press this for a while, but it doesn't seem to work. Okay, it's the R button. So pressing the R button will get you in auto mode again. One thing that it's cool, if you press again this, it will stop. Okay, it will freeze the value on the screen, but in this little box it will show you the current value that is being read at the time. If you press again, you take this out of the screen, and as in the oscilloscope, if you press once again for 2 seconds, it will show you the DMM database. In the DMM database you can save this value, and this is currently on milliamps mode. Let's go out of here. Let's see if I can get out. Yeah, like this. We have also the amps modes, everything is equal but in amps mode. But what I want to see is, for example, if I save something. Okay, let's first put this on stop, then we will enter the DMM database. Okay, and the DMM database has much more capacity for saving, so 100 records. And what I want to do is save here the value. Okay, it will save everything on this list. It will not has a list for milliamps and other for voltage. It will have everything in here. I don't know if this will work, for example, for continuity. Let's check. Okay, I don't think it does much sense, but let's see it. Yeah, it seems it does. And it will save here the it has a small speakerphone symbol and the registered value. So it's a very nice feature, and in terms of operation I think that we have it covered. So let's do some testing. I will start by testing the oscilloscope and then the multimeter. For oscilloscope testing, I have already my function generator outputting 1 kilohertz sine wave. We will take it to the maximum, that is 10 megahertz, and see how it handles. Right now everything seems okay. If we come here to the time division and open a bit, the sine wave is perfectly drawn. We can even increase a bit the amplitude, like this. So it's okay. Let's take this from 1 kilohertz to 1 megahertz. Let's jump to 1 megahertz auto, and let's see what we get. Okay, obviously the sine wave, it will become much closer, much smaller. We have in here 1 microsecond, so we can even increase right now the time division. Let's see what we can do about it, or decrease the range. So 200 nanoseconds is the minimum that we can go, or maximum zoom. So still okay. It has a little deformation in here, but basically it's okay for me. Let's take this to 5 megahertz. Okay, automatically adjust. It reads the value correctly. Okay, 5 volts peak to peak, that's what we have on the signal generator, and everything seems okay. Let's do an auto, and basically it keeps on the 200 nanoseconds range. So this is what we got. Let's change here. In terms of the sine wave, we start to see it compressed. So overall it seems a very stable waveform. 5 megahertz, totally on spot in terms of frequency reading. So let's move this to 10 megahertz. I think 10 megahertz. Okay, let's do an auto again and see what he shows. It's very hard to read this. It oscillates a bit here in 10 megahertz. So this is the maximum this device is reported to handle. The sine wave still seems very stable. It oscillates a little bit, but seems very stable. And in terms of readings, we still have 4.80 on the voltage peak to peak. Not bad. For this value and the functions it has, it seems okay. I'm okay with this quality. So the sine wave is still very stable. Obviously you don't have much sampling rate, it's 50 megasamples per second, but it will do. So in terms of sine waves, that's it. I will change this once again to 1 kilohertz and show you some square waves. Okay, let's do it. Auto. Seems well drawn. for 1 kilohertz. That's the normal for calibrating. Let's do it, yeah, like this. Okay, more or less 90-degree angles. Don't forget, this is not a probe, this is just a cable connected to oscilloscope, so it cannot be compensated. Yeah, but it seems okay. Let's increase a bit this to, I don't know, 100 kilohertz. Yeah, square waves are always more hard to have, but even so it seems better than the previous voltage of 1 kilohertz. So yeah, the squares are 90-degree perfect, so very nice. Okay, 1 megahertz. Let's do this in 1 megahertz. Okay, now we start to see some differences. Let's increase here the waveform. No, not so much. Going again to time. So in 1 megahertz we start to see some problems with the square wave, some oscillation, but even so we still have 90-degree angles, but we start to see some deviation here on the top and in the bottom. So nothing serious, but yeah, it seems more or less okay for 1 megahertz. Don't forget that the square waves require much more from the device than the sine waves. Just to test, let's increase this manually and see what else we have. So right now we are on 3 megahertz, and this seems everything but a square wave. Okay, so I will say that the maximum that we can have for square wave is something like 1 megahertz. Something I like to do is to show how an arbitrary waveform will appear. I have this heart-shaped waveform. Let's see how it draws. So it seems pretty well. Let's see if I can show you with better contrast. Nothing here, exit. Yeah, this is the best I can do. And yeah, well, it seems to draw this pretty well, so pretty happy with this. Okay, so let's move on and pass to the multimeter testing. To test the multimeter, I have here my DC voltage calibrator outputting the voltage. It is connected directly to the Tooltop ET828 Pro, and then on the entry I will have also another test cable connected to my Siglent SDM3045X multimeter to to give a second reference on the signal. So I think that we are set up. Let's start testing with 1 volt. So we have 0.998 on the Tooltop and 0.9997, so basically 1 volt, almost there. So yeah, 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, 9 volts, and we are back to 0. Okay, moving on to the millivolts range. So let's start with 100 millivolts. Okay, 99.9, not bad. The Siglent is spot on. 200, 300, 400, 500 millivolts, 600, 700, 800, 900, and we are back to 0. Okay, So moving on to lower millivolts range, let's start with 10 millivolts. Spot on both basically. 20, 30, 40, 50, 60, 70, 80 millivolts, 90, he missed one. Yeah, it's almost there, and back to 0. On this range it is totally spot on. Let's move to 1 millivolt to see what we can read with this. So 1 millivolt, oh, he's able to detect that. 2, 3, 4 millivolts, 5, 6, 7, 8, 9, 10. So back to 0. Okay, I can go to the lowest of my scales, microvolts, but I don't know if this will be able to see this. Okay, it is. Oh, 2, 3, 4, 5, 6, 7, 8, and 9. So this really excels in millivolt readings. Very nice. It has a very small difference in terms of voltage, but in millivolts it's really good. Okay, moving on. If you follow my channel, you know that I created this board. This is the voltage reference board, and this was created before I have the DC voltage calibrator to test the millivolts of multimeters. Some of the multimeters are able to see the 5 volts value in here, and some are not. So I always like to test this. It seems that this entered in autosave mode. Okay, and okay, let's see what are the values that we are going to have here. As always, I have my Siglent doing the backup reading. So let's start with this one. This 10 millivolts. Okay, 10.5. So it's mostly the same value that we have on the Siglent. Only one, no, not even. It's spot on. So 25 millivolts, 25.1 and 25.12, very good. 50 millivolts. Okay, we have 1.1 difference. 100 millivolts, 99.8 and 0.87. Okay, fair enough. 250, and I believe this is 200 and something, but not 50. Okay, this is not good. Both multimeters are giving me the same voltage, so this used to be 249 and right now it's 338. So I believe that I might have a problem here with the resistor. Okay, but the values are accurate because both multimeters say the same. Okay, 500 millivolts, 501 and 501.38. Okay, within the specs. 1 volt. Okay, 0.998, 0.99888. So, okay, and 2.5 volts. 2.487, 2.489, and the final one. Let me see if this can read the 4 point something near 5 volts, and it can. This is really nice as a multimeter, very nice, and also as an oscilloscope. Okay, I think I will put this board to rest. I will not take any more time repairing this, because we have here a 250 problem. Something is going on with these resistors. Whoa. I just moved something here and it changed the value, so we are back to 250, 59.6, but yeah, what is going on here? This is the original value, 248. Something is going on here. Yeah, this is totally screw up. I think that this resistor, it's not good. So even if the values are changing, we can see that they are more or less accurate between multimeters. Okay, that's it. Let's move on to the other measurements. Now it's the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. For resistance, I have here my precision resistance reference board. This has 0.1 resistance resistors. So let's start by the first one. It should be 10 ohms. Okay, 10.2 ohms. Nice. Okay, let's move to 100 and something 0.4, I think, or 01. 100.01 ohms. Still good. 0.9991K. So it's 1K. Okay, good enough. So we have 9.999K. 10K. Okay, it rounded. 99.97, I think. Let's see. Also 100K. Or 99.9. Okay, seems very good. So now comes the capacitance part. The first one is 104 picofarads. Let's see what we have. 110 nanofarads. Yeah, it's oscillating a bit. Let's see if we can. Yeah, that's it. So next we have 1.04. Also, this is nanofarads. 1.053. Okay, it's close. 10 nanofarads. 9.94 nanofarads. So 104 nanofarads. Okay, almost spot on. And 981 nanofarads. I don't know why, but those always fail a bit. So we have 952. And we have 10 nanofarads, microfarads, sorry. Yeah, 10.78. Yeah, it should be 10, but it's close enough. It's almost 11. Okay, let me test other boards. These last two. So we have 952 here. Yeah, it's always a bit off, but this is with every multimeter. It's not from this one. I even bought other boards. So this is 9.80. Yeah, a bit off. As you can see, I have numbers for each one, and this is the original one that I always tested. So this one should be 929. Let's see what we get. Yeah, way off for 50 nanofarads. And this one should be 10 also. 1050. Okay. It seems consistent. Let's move on. For diode testing, I have here the usual suspects. First, I will test this diode. It should have a gain around 600 millivolts, like that. Okay. Let me change. It shouldn't detect anything on reverse. Okay, perfect. So we have here, I believe 1.74, yeah, a diode. It turns the light, so pretty good. Also, this one is also 1.7, and this should be 2 point something, 2.6, I see, yeah. So it seems okay. So this device has a big beep. Let's see, it's a big beep that I cannot turn off. So let's see how it works in terms of continuity, if it is fast to beep or not. It seems fast. It will not update the screen very fast. Let's see how much time it takes to update the screen. About 1 to 2 seconds to update the screen. But in terms of sound, it's very quick to trigger. Yeah. Damn, this has a loud beep. I don't know if you can hear, but yeah. So that's another one tested. Let's move to frequency. In terms of frequency, I connected this device again, this multimeter again, to my function generator. And I will start by outputting a 1 Hertz sine wave. And let's see which frequency it will detect. Okay, it's on. So it detects 0.999 Hertz. Okay, let's move this to 10 Hertz. Okay, 9.999 and 100 Hertz. Okay, always one digit off. Not bad. Let's move this to 100 kilohertz. So 99.9 also, and 1 megahertz. This multimeter can go up to 20 megahertz, and they say that everything over 20 megahertz, it's for reference only. So they certified that this is able to test any frequency up to 20 megahertz. Right now we have 1 megahertz, still one digit off. Okay. I have a 5 volts BPP in the signal, so let's increase manually the frequency until the 20 megahertz. So 2, 3, 4, 5, 6, 7, 8, 9, and 10 megahertz. So the digit off is constant. Yeah. I don't know if it requires calibration or not, but let's continue. 11, 12, 13, 12, 13. On 13 it starts to have the spot on figure. 14, 15, 16, 17, 18, 19, and 20. From the 15 over, it is spot on. in terms of frequency. Let's continue to see when it starts to derail. So I will move to 25 so it will not take too much time, like this. Okay, 25, 30, 29, 30, still spot on. Let's take it to 35, okay, 40, oh, 45, still spot on, 50. Let me just change the decimal to see how it will handle. Yeah, 4, 5, 6, 7, 8, 9, 10. Amazing. Okay, still very nice. Let's move on this to 75 to see if we can handle. So 75 megahertz. Whoa. Okay, let's go up to 100 megahertz. It's for reference only, but yeah, 100 it is not working. Let's 99. Let me change here. Okay, 90, 80 megahertz. Well, it is able to go up to 80 megahertz. Let's see, 81, 82, 83. I think it takes a while, but it goes there. 88, 89, 90. Amazing. No, okay. 91 is the maximum. After this, it will go bananas. Okay, I think it's the oscilloscope. Sorry, I think that's the multimeter that I had here that is able to read more frequency, up to a higher frequency. Very nice. Okay, let's see in terms of frequency. In terms of duty cycle, well, duty cycle is quite crazy right now. Let's go back to 1 megahertz and see what it says. Okay, 48.88. I think that's the in duty cycle that we will have a bigger problem. So right now I'm in 5 megahertz, 49.55 in terms of duty cycle, 10 megahertz, almost 50%, 15 megahertz, okay, still, and 20 megahertz, 49.50, 60, yeah, around that. Okay, seems good. Let me just take to 50 megahertz to see what happens. Okay, still on 49% duty cycle. Seems okay. Let me put this at 100 hertz to see the duty cycle. Okay, it's the 50%. 100 kilohertz. It's already on 49. So if I got 49 at 50 megahertz, I'm pretty happy with this. Yeah, 49 point something. Okay. So in terms of frequency, that's it. For milliamps measuring and testing, I will be using my SG004A FNIRSI source signals generator. I will be generating a current between 0 and 24 milliamps. So let's start and see what we get on the Tooltop ET828 Pro. 1 milliamp, 2 milliamps, 3, 4, 5. We are a bit on the side, but I think that I might need to calibrate this one. Even so, I think it is between the limits, error limits. So let's take it to 10 milliamps. Okay, 9.98 and 15, 3 decimal, yeah, 2 digits off, 20, also 2 digits off, and 24, it's the maximum, also 2 digits off. So not bad. I can try even to see what we have here on amps. So we have 0.023 amps. So basically it's 23 milliamps, of course. And at 20, 1 digit off. 15, 1 digit off. 10, 2 digits off. And 5, 1 digit off. And 1 milliamp is not detected. Only 2. Yeah. So that's it in terms of milliamps and amps. Now I will measure some AC voltage. This is 220 from my mains in the house. Let's see what we have in here. So 234 to 35, this is the normal I have. It sometimes goes up to 240. Yeah, that seems fine. Now it is teardown time. Okay, so I removed the board, and what we have here is this small LCD, the rotary knob encoder, and also in the front some contacts for the function buttons, nothing else. On the back we have the electronics. The contacts of the knob are made with these metal strips, yeah, and that's it. So I have the board here in the microscope. This is the bottom where the connectors are. You have on this corner a 10 amps fuse, another one of 1 amp. If you go down, or in this case up the board, you will have here this, I believe it's ADC. It's scratched or burnt, but yeah. So, and we have this H24C02. This is a 2-wire serial EPROM, 2K EPROM. So yeah, let's go a bit to the center. Let's see what we have in here. And near the batteries, nothing special, but we have here this MS9280. This is a 10-bit 35 megasamples per second AD converter. And over here, I believe, let me show you, we have here what I believe to be a rail-to-rail amplifier. I have one here and another one in here. This is the 8091. So we have 2 octocouplers in here, the EL3H7, and this one is a mini relay. A bit down or up, whatever, to the side, we have this ARM processor. It's the STM32F400 RBT6 line. I didn't find, even on the STM website, I didn't find the specs for this line. So you have on the screen the specs for the 401. Normally those processors are quite familiar, only a few changes on the speed or on the memory, but nothing too serious. And I think that's it. We have another EPROM in here also, and a crystal. Yeah, that's it in terms of components. This is the connector in here below this strip for the screen. Here is the ribbon for that. And on the right side, we don't have much normal components. Yeah, nothing special. wrap-up time and I can't continue without talking about the price. This device is for sale on AliExpress for €37. Well, to be more accurate, almost 38, so this will be something like $40 give or take. This starts to enter in areas of small devices like oscilloscopes that have supported bandwidth of 200 or 500 kHz, with the plus of the ET828 Pro is also a very precise multimeter. As an oscilloscope you will not get any special functions. You pretty much have the basic waveform, change of time division, amplitude and triggering, auto function and waveform storage, and that's it. On the multimeter part, the readings were precise and totally within the specs, and some of them were spot on, especially on millivolts readings. This is a personal preference, and I know there is a lot of disagreeing opinions on this, but I will prefer to have a USB charged battery than the AA batteries, even if I agree that in some cases might be useful to change the batteries to be able to continue working, instead of having to charge the device. But for me, it's still preferable to have the internal battery. I understand that this will also increase the cost, so also understand that to keep the price as low as it is, this might have been a commercial decision. You don't have any special and amazing functions on this device, but it does in a very decent way what it's supposed to do, with a very attractive price. The usage is good and you just take a couple of minutes to get acquainted with the interface and operation. This device will work very well for everybody, but if you are a novice, this will be a very accessible device and will allow you to explore both analysis on the oscilloscope and have also a decent multimeter for your electronics. The overall experience was good and I like to review this unit. If you liked what you saw and are considering that this will be a good choice for you, please remember that if you want to help the channel, you can always use the affiliate links on the screen or in the description before your purchases on AliExpress or Amazon, and sponsor this way the channel. Some price to you, a big help for the channel. And if you found this video useful in any way, please slap that like button. And also, let me tell you that I receive every week new equipment for review. Some are even world firsts. And subscribing will help to keep you on the loop with what's new on the market. Thank you for watching and being with me. I hope that you liked and you will join me on my next video. Until then, stay safe.